This is the first of 3 examples that will illustrate how to interpret, first of all, this notation. That's really the important part here, is to know what that notation means, but then to find the area under a curve from one number to the next and get some sort of an answer out of this. So when we do this, a couple of things that you might want to notice. We've got -1 and 4. Those are going to be the boundaries on our integral in this case. And so I'm going to go from -1 as kind of my starting point. It's an x value, so I'm just going to draw a dotted line at -1 because that's basically where I'm starting. I'm going to go all the way up to +4, and so I'm going to put another dotted line at 4. That just shows me my range of values that I can do. I'm going to go between -1 and 4. Now the other thing that we have here is that it says 6. Now 6 is the function. That's a pretty basic function here. That's just y equals 6. And as you probably know, y equals 6 is just a horizontal line. So that's this line that's going right through here. Now, what this whole interval means, though, is it's going to ask us basically for what is the area under this function between -1 and 4. And we're only going to go down to 0. So what this means here is we're going to be talking about this rectangle. What's the area of that rectangle is essentially what this problem is asking us to do. Now, since that's such a nice, neat geometric shape, we can simply find out the dimensions of it. So from here to here, we have a total of 5 units. And then we know that from here to here, we have 6 units. And so our area in this case is just going to be 5 times 6. So as you can see, a lot of this is just interpreting the notation and then applying it to the graph that we see here. So 30 is going to be our solution for the definite integral of 6.